Action. This is not working. There we go. Okay. Eyes up here, voices off. Sorry about that. Okay, so if you take a look, up here, just a few things to keep in mind that are ahead. And Jonathan, just so you know, at the beginning of a unit, I'll give you all this calendar. At the beginning of each week, you'll get your notes for the week and your homework for the week. So you've got your problem set and you got your notes today on a Tuesday because yesterday was weird. Okay? So this calendar right here, you'll see today is going to be our first lesson, and the kind of cool thing about this unit is we're going to add a little bit tomorrow, a little bit Thursday, but actually we're going to be practicing pretty much the same thing all week, graphing trig functions and then transforming them and like moving them around. And then on Friday, you'll have a little mini quiz. Originally, you know, Friday wasn't like school, and so this was like a long weekend, so I actually won't be here because I already like forever ago booked flights. We didn't see my husband's family over Christmas. Our plan was to see them this long weekend so we could do my family and his family. So I'll be gone. But you'll be taking a quiz, so it'll just be some random person watching you take the quiz. I don't need to be there to watch you take the quiz anyways. So you're going to do that. And then next week, you're going to keep going with some graphs of sinusoidal functions. And then we will take our unit exam on Friday. So notice there's not a review day between this last lesson and that test. I try to get those as much as I can, but this unit we don't have space for it. So that means you're gonna like learn all this stuff and need to show up the next day ready to go for your unit exam, okay? So just a note there to be aware of as we move forward, okay? Other than that, you've got a problem set that you just got that is due because we don't have school on Monday. They're usually always due on Mondays, but it's going to be due on Tuesday. You've got till the end of the day, 4:15-ish, to get it in my inbox. And remember, we've got the goal, if I can get 100% of your class to have that turned in on Tuesday. And if you notice, it's just like front and back. It's not that bad this week. If I can get 100% of you to turn it in on time by 4:15, then we will discuss happy things for this class moving forward. Lots of prizes and fun things. Okay. And then, last but not least, in terms of business, it is also, not only is it the beginning of the unit today, but it also happens to be the beginning of A4. So, we have a new tracker coming your way with, like I mentioned yesterday, some small changes. So, Jonathan, just so you know in general how this works, you get one of these at the beginning of every grading cycle, and it stays with you all the way until the end of A4. A couple days before A4 ends, I will grab it, and however many points you accumulate based off your participation will be your participation grade. Now, in this class, and some of my other really big classes, it can definitely be hard for me to call on enough people sharing out whole group for you to accumulate a lot. So one thing that I'm going to kind of add in for this, as long as I can kind of like trust you guys to be mature about it, is I want to promote more just like, not just sharing out discussion, but also just when I turn and have you guys work in groups, like I got a lot of still like independent work going on, and like I want more collaboration and actual math talk rather than like off-topic conversations. So you guys are going to be able to kind of reward each other and sign off on participation points if your neighbor teaches you something, shares something wonderful with you, asks you an important question, something like that. Do you feel like if I was sitting there, I'd be like, that's awesome, and would like sign off on? I'm gonna let you guys use your judgment, and you get to like initial or sign, and I don't need to stamp it. That's gonna count as a point. Now, so Samantha turns to Juan, and she's like, I said that my answer is this, which is kind of similar to yours, but it's different because, and they have this great conversation, and they sign off each other's paper. That's a great example. If Samantha just turns to Juan and is like, hey, how was your weekend? Like, yes, they're having a conversation, but that's not going to be something that I expect y'all to be like just signing people's paper for nothing. Okay? Does that make sense? So you should be able to use your judgment, and I'll kind of monitor, and we'll kind of just see how it goes, test run that new edition. On the back, I got some sentence stems to help you out. So you can even participate when you're stuck, or when you agree, or when you disagree, or when you need clarification or things like that, okay? So I'll pass these out, everyone gets one. Put your name on it first, because I've actually got a lot turned in that I had to sort out last night, because they had no name on them, and I had to like kind of try to figure out whose they were, and they all look the same. So if you can write that off today, or write that on there today, then we won't have to worry about it later. That would be wonderful. Very good. Alrighty. 1, 2, 3, 4. Have we got a question? Are you ready for them? Oh, sorry. Yeah. Okay, anyone else missing one? Dun, 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 dun. We are ready. Okay, today, graphs of trig functions. And I know you guys, from talking to Frank, I don't know if y'all were y'all in the school park together? Yeah, okay. So you guys did, it seems like pretty much this unit, you did like all the trig stuff, and we did like half before, and we're doing half now. There's a few things that when I went through his stuff that we did, like a unit, that it doesn't seem like y'all touched on quite as much. So it's a little bit jumbled around. So these next 2 weeks will look pretty familiar for you probably. Okay, so graphs of trig functions. We're going to look today at 2 graphs that are going to be kind of like our main parent functions for this unit. The graph of sine and the graph of cosine. So if we recall our unit circle, if we look at the coordinates around the circle at different angles, it showed us sine and cosine. Today we're going to look at like sine, just sine. What happens, what is the pattern in the values of sine as the angle gets bigger? And then we're going to look at just cosine. What is the pattern in the cosine values as the angle gets bigger and bigger and bigger? So we're going to start with this one. This one's find the graph of, take a look at your notes. Graph of which one? Sine. So circle that. We're going to start with just sine. It's important for us to know which one we're looking at. So we're going to look at sine first. And remembering back before break, before you were doing whatever you were doing and sitting on your couch and playing Xbox and all that stuff, who remembers which coordinate from our unit circle that sine was paired with? Sine was our what coordinate, Jason?
The y.
The y. So we're going to be looking right now around our unit circle at the y values at different angles. And I could look at all the angles, but I already chose some friendlier number ones, like pi over 6 and pi over 2 and 5 pi over 6, where you're going to notice the sign at those points is like 1 or something like that, not crazy numbers like root 3 over 2. Okay, and we're going to plot them. So I'm going to do about 3 of them with you, then I'm going to let you finish it off and kind of notice what the graph looks like. So let's take a look. If I start, and I notice right here, I've got all these different angles on my x-axis, and I want to see what is the corresponding y value that goes with that. So if you'd like to kind of organize this in a chart with your angle and your sine value, and then we're going to plot the points. Let's start with 0 before we get to pi over 6. So everyone picture 0 on your unit circle, or if you are having trouble remembering that unit circle that we at once had memorized, then maybe peek at a unit circle at your table or up here at the board. And what is the y or sine value at 0 radians and 0 degrees? Chimay. Take a look. Sorry. Over here at 0, the y value is 0, right? So we've got the point, the angle is 0, the sine is 0, so that is the point 0, 0. Okay, we're going to do 2 more. Let's try pi over 6. If our angle is pi over 6, picture pi over 6. It's the first angle that we put on our unit circle right here. Raise your hand. I'm going to wait for some more hands this time. What is the y value or the sine of pi over 6? I got 1, 2, 3, 4, 5, 6, 7. Oh, there. Just didn't want to raise a hand. Samantha. 1/2. So 5 or 6, we got 1/2. So we're going to go up to 1/2, draw a point right there. And we're noticing what's happening right now. Our sine value seems to be increasing. Let's go on to pi over 2. Last one we're going to do together. Then you're going to finish it off. Pi over 2. Try to do it in your head if you can. If not, you can peek. Diamond. It's up there at the top. The y value is 1. So we are right here. Got it? So go ahead. Keep going all the way to 2 pi. I want you to see if you can see the pattern. What does this look like? Make some observations. Be ready to share out. Okay? Go. Would you like another copy? If anyone's in desperate need of a unit circle because no one at their table has it and they can't see the board. 2 pi over 2. You don't have to. You can plot all the points in between and it's just going to make your graph like a little more precise along the way. I just chose ones that have like ones that are nice and friendly. Notice these. You like don't necessarily know like the decimal of that off the top of your head. So it just would slow us down a little bit. So I just chose the ones that have friendly numbers of 1/2 and 1. The next one I chose this one. And so on. So yeah, that's just I just chose to do that. You don't have to. Need another one? Anyone else in desperate need of the circle? So we're gonna tomorrow get more down to like the periods. Today is more like what is the period conceptually. Tomorrow we're gonna say like now we can just do 2 pi. So cool.
Oh, yes.
Any AQR people? You want to take a look? Or y'all juniors?
It's negative. No, it's not.
Right, so does it matter?
No, I was in AQR. I'm pretty sure.
And now y'all brand new for y'all. And so my other classes are like. Okay, take a few more seconds. Once you have it, you can go ahead and like connect the dots and have a grand old time and kind of see what it looks like. What is the general shape of the graph? What are we seeing happening here? There we go. All right, about 5 more seconds. 3, 2, 1, and we are back. So, general observations real quick. I'm not going to plot all of the points, so if I wanted to draw a sketch, who can kind of describe to me generally what the graph looked like and just describe in your own words? Adrian?
It'll go down the same way it went up.
Okay, so it's going up. Then you said it's going to go down the same way it came up.
And it's going to pass through negatives the same way it went up.
And it's going to do the negatives pretty much the same way
Yeah.
down here. So we end up with this, like, some people describe it as like a wave, or someone in the last class said like squiggly, or like a sideways, backwards S, all sorts of things. So this is going to be a sinusoidal wave. Sine and cosine are what we call sinusoidal waves, and they're functions that go like this, and they oscillate or they repeat and things like that. Because notice, after 2 pi, this technically doesn't have to stop. So eyes up here really quickly. If I were to go all the way around the unit circle, I could actually keep going to angles bigger than 2 pi, and these values would start to repeat again. I'd be on the same spots around the circle. So it's actually, if you graph it in your calculator, just keeps on going like this forever, and same thing in the negative direction, okay? So it just bounces between 1 and -1 the whole time, and it starts right here in like the middle of the wave, the sine function, okay? If you want to see a pretty version, because you don't like mine, that's like from the internet. Okay, next, flip. the page. What does the next graph say to graph? Cosine. So we're switching gears to the land of cosine, which Juan says is the what? X value. So now we're going to go around the circle and we're going to just jot down the X values. Now we'll pause because I kind of screwed up. I got lazy and kind of like was like, oh, I labeled one graph and then just like stopped thinking about it and labeled this one the exact same. The other one I chose pi over 6 values because they were nice, like 1/2, and I knew you guys would know how to graph that rather than like root 3 over 2. I meant for cosine to do the pi over 3s. So I'm going to change this up really quickly. The way this is labeled, really quickly, you actually don't need to do pi over 6. You can, and it'll be on the curve, and it'll be fine. It's just some weird decimal over here. I want you to do pi over 3, do these green ones, pi over 2, 2 pi over 3, skip pi over 6, it's going to be messier, pi, you can skip 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, skip that guy, and finish up with 2 pi. So all the pi over 3s, and then all of the pi over 2, pi, 3 pi over 2s. Okay? No more pi over 6s, because they are just not friendly numbers. They're points, but they're not friendly. Okay? So let's do the same thing. Angle, but this time we're going to be finding cosine. We're going to look at all the cosines and notice the pattern of what's happening with them. So if we start at 0, let's just do 1 together this time, then y'all can do the rest. Everyone think about 0. At 0, not the y coordinate, what is the x coordinate this time? Cristobal. 1. Over here we got 1. So this graph actually starts up here rather than at the origin. Okay? Go ahead and keep on plotting away. I'm going to come around and catch up on stamping some people that have already shared some answers and see what you notice. So, no, because in general, the way around the circle, these are like increasing and decreasing, is going to make the same shape. But it doesn't necessarily mean like if you take a string and like mark off these points and like try to lay it out, like this arc length is not corresponding necessarily to like this arc length. Like all we're graphing here is now the relationship between like just like if I just look at how these angles are growing, getting smaller than the pattern is. So this is the graph of cosine of x. So if you graph in your calculator cosine of x, it's going to look like this, but it's going to look a little bit more if you graph in your calculator like this. And if you picture it continuing to go on and on and on, it'll just keep repeating like that. So it just starts at the top of the wave, where this one started in like the middle of the wave, right? But it still goes between 1 and -1. Okay, I see most people traced their picture, and it looks beautiful. Eyes up here, make sure it matches mine. It should go. Oh gosh, this is hard. Roughly something along those lines. Okay? Now, if you picture this continuing to go on and on and on, some people made it a little more like pointy like this, but it is still a curved sinusoidal, like wave-looking thing. That would, sinusoidal means it's a sine or a cosine graph that has this general pattern. It actually, in some ways, is very similar to our sine graph because it's still going up and down between 1 and -1, right? Except, what do you notice about the difference between this wave versus our sine wave? That's kind of one of the big differences between this cosine wave and our first sine wave. Jason?
Okay, so for the first sine wave, like we started at 0, and then with the cosine we started at 1.
Yeah, so if you look at these side by side, take a look up here, and this is on the next page if you want to look. The wave looks really similar, but just like Jason said, this one's starting kind of almost in like the middle of a wave at 0, and this one's starting up here at 1, at one of the maximums of our function, like that. So it's almost like this part of our wave for cosine is shifted over. They're really just horizontal translations of each other. Okay, so you could write a sine function in terms of cosine and a cosine function in terms of sine, and we're going to do all sorts of fun stuff like that this unit. Okay, so this is sine and cosine. The big idea when you walk out of here is to make sure today that you have a sense of what they both look like and some of the differences. At the end of class today, we're going to kind of do, like I was saying, more of these like exit ticket independent things. So in our last like 5 minutes, y'all are going to kind of walk out of here independently without looking at your notes, trying to like draw these and make sure you got the key points when you leave, okay? So make sure you got it. Cool. So let's go ahead and write down some of these characteristics of these graphs in our notes. So we got them down and we can reference them whenever we need them. And then we're going to move on to the fun stuff and start doing some transformations, moving them around. Cyril, take a look. Let's talk domain and the range of our sine graph. I'm going to kind of walk you through this one and then have you guys kind of share out what you think for the cosine one. For our domain and range, Juan, you got an idea? Because anytime we have sine, I know I say sine a lot, which I probably should always say sine of something. Sine by itself doesn't mean anything. It's a function, so we have to take the sine of an angle, right? So x is what we plug in our angle. Okay, so that's what our x is. So for our domain and our range, our domain is, these x values, which is our angles. Our angles go all the way, keep on going forever to negative infinity, and all the way keep on going to positive infinity. This whole graph is continuous. We could trace it with our pencil forever and ever and ever from negative infinity to infinity. Okay? Now for our range, we're talking y values. And I don't actually go down, down, down forever. Where's the bottom of our graph? Anyone? Negative 1. So we're going to go from negative 1 up to, and then we also have a top positive 1. So negative 1 to positive 1 for our range. Okay? Jot that down. Yep. The range. So we start down here at negative 1 for our y values. There's nothing below negative 1, and there's nothing above positive 1. So we only want between negative 1 and 1. Cool. Then for your y-intercept, that's right here. That's at y equals 0. That's where it crosses the y-axis. You can just set it there. I'll get it. For our continuity, remember that kind of has to do with our domain. So since this is all real numbers, like that means there's no breaks or holes in our graph all the way from negative infinity to infinity. So it's continuous for all real numbers from negative infinity to infinity. Alright, bonus points for symmetry. Let's see if one of y'all can try to figure out what type of symmetry this has way back from beginning of last unit. So notice like this is reflected across like this. It's doing like the opposite thing. Those points are reflected in that manner. So does anyone remember what type of symmetry that would be, Chime?
It's like reflected off the origin?
Around the origin. So it has origin symmetry. Another way to say that is it is an odd function. Remember yesterday, like when we were talking about that graph that was missing part of it, it was odd, which meant we knew it had origin symmetry. So those are things we kind of keep hearing. Still with us, Carmen? Okay. And last but not least, extrema. Now there's lots of them. There's tons of points across the top, tons of minimums across the bottom, and maxes across the top. So we're just going to write all of those happen at lots of different x values, but all of them are happening either where y is -1 or where y is +1. That's where we have all of our points of extrema or absolute minimums and maximums. I'm going to come back to end behavior once we talk about cosine. So now that I kind of walked you through sine, let's rapid fire through cosine. I'm just going to take lots of volunteers that can kind of compare and think they can fill this out. So first up, Jose, domain.
It's the same, like negative.
Same thing, negative infinity to infinity. Range, who's got it? Jeannie.
-1 to 1.
Same thing, -1 to 1. Y-intercept, Adrian.
Oh, +1.
+1. This time it's up here, not at 0. It's at +1. Okay, continuity. Is it continuous or are there some breaks, Maggie? Yep, all real numbers. Negative infinity to infinity. Symmetry. Let's see. Jeannie thinks she's got it. Go for it.
Even
It's even, which is what type of symmetry?
across the x, the y axis.
Y-axis, across the y-axis. So notice, like, for example, if you pick this point, it's reflected just right across the y-axis. If I folded my paper on the y-axis, everything would match up on either side, right? Okay, y-axis symmetry, it's even, and then I'll finish the last one, same thing for extrema, right? Okay, extrema, yeah, so think extrema is a vocabulary we learn for like the extreme values is how I like think of it in my head. So any maximums or minimums of your graph. And notice the high points and the low points are happening at 1 or -1. Extreme. Yes. Okay, now you never forget. Okay, next up, end behavior. Let's close this off so we can get to some transformations. I wanted to kind of talk about this for a second because we've talked a lot about end behavior, but we haven't ever really seen any graphs like this before. So we've talked about end behavior with limits. The limit as x goes to -infinity, the limit as x goes to infinity, and y'all have described if the graph goes up, 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 what's the end behavior? Positive infinity. If the graph's going down, down, down forever, you would say negative infinity. And if it's approaching an asymptote or leveling off, then we would say it's approaching like whatever it's approaching, 0, or maybe it's leveling off at 1 or something like that. Now this graph, picture, are we going like this, leveling off? We are going like this, right? So I'm not going up, up, up to infinity the whole time. I'm not going down, down, down. I'm not even leveling off. So our end behavior here, we can't really describe that it has one behavior, right? So we can say none. It's not going to be something that we're describing like we typically do with our limits. So I just wanted to point that out. If you ever see something like that, this is kind of a weird case for our end behavior. All right. So you got all the main key points. This is a good table to come back and reference about sine and cosine the graphs. Now, what happens when you don't see sine, but you see 2 sine of x? And you plug that into your calculator. Most likely, it's very similar to the sine graph, but we're going to talk today about how these transformations are going to change our graph. So I'm going to call a value in front of our function, a. I'm going to call a value inside our function being multiplied, b. And I'm going to call a value on the outside of our function being added or subtracted, d. I'm purposely skipping c today because we're going to talk about it later this week. So today we're going to focus on these 3 types of transformations. And in order to figure out what happens, we're going to do a little card activity. So first up, I'm going to give you and your group a set of green cards. All of these green cards have either sine or cosine graphed, and then another graph where it has a value of a in front. Maybe 2, maybe 10, maybe -4, maybe 1/2. And I want you to notice what it does to the graph so that you and your group can answer the question, what do you notice about the impact that a has on the graph? Got it? As soon as your group's done with that, I'm just going to be circulating. I'll switch out your cards. I'll give you a set of red cards, which is about B, and then a set of white cards about D. Got it? So you're answering these 3 questions figuring it out yourself from the cards. And this is a great opportunity to give each other participation points. When someone shares something amazing with you, okay? So unpaperclip them, spread them out, compare them. Don't just hold one of them because it's kind of hard to tell unless you really look at all of them together and how they're different or the same. So spread them out, take a look, talk about it, see what you can come up with. Like how I look at what is the value of it. So before, technically there was a 1 in we can see it, so that's why it's up to 1. Now, 5 means it's going to go forward down to 5. If it's a negative, instead of going up to 5 like this, we're going to go first down. So these are just technically sine rules, so they're all starting at the origin. Sine, it starts at the top and still goes up or down. If it's 1/3, it's going to not go all the way up to 1/3.
Yeah, basically
That's 2. So we got down that right here. What did it impact? What did it affect? Paper clip it back and then go on this way, okay?
Sure, if you bought them, just put it.
Okay, once you guys shut that down, everyone at the table has got an idea what's happening with A.
I feel like if you're at a party and you have a beer or something, you just have one shot, you're gonna take it.
Y'all ready?
I think you are.
Question?
You don't know, you never tried it.
So horizontal strength.
Addiction.
You would have taken this original graph.
Here we got this.
So we're still talking for all of these about vertically, compressing or stretching with the fraction. See how it is compressed when it's tall and when it's
Ready?
this is divided so it's really affecting like our relationships, right? Okay. So kind of try to write down your best kind of summary of that, and then go on to B and here for the back for me. Ready for the next one?
Wait.
Go got an idea what's happening with A? Which direction? Like this or like this? Vertical. So say vertical and stretch, and then pick up those back and then try to. Y'all ready for the next one? Wakey wakey. Can you pick up those back and go on A and then try the next one? You write anything down for A? Piece up for me. Since you don't have it, it's fine if you have it, but if you don't have it, then you just get up straight. You're good. Okay, there we go. Moving on to the next one. Moving on to the next one. Okay, we'll put those back for me. Uncook these. Come on, touch them. Okay, so let's take a look at this one. It's on this one. What do you notice as we change this value from just x to 3x, 2x, 3/4 of x, 1/2 of x? What is going to turn the weight there? What do you notice? Like, it doesn't have to be Superman. What do you notice about this highlighted graph versus the original? Yeah, so it has to do with like, yeah, like how weighty it is and how many weights we have. So see how here you have one weight on the original graph? It goes down and it goes up. Now we have down and up, down and up. So we have some weights. Right? How many weights do you think you're going to have here? This has to do with how periodically, like our wave is repeating. for a fraction, it means we don't even have a full wave. We should have only like 3/4. So we always get back up. We should make
What you see?
So for B, B's the value inside. So right here, what impact does it have on the graph? We can say something about like how often the wave repeats.
So what you
Write that down, and you're gonna go on to the next one. We're gonna go on to part C. So drop something down for B. Yes. You guys do the last one? You ready for the last one?
smart.
No, yep, wait. Ready for the last group? Are we done with red? Any paper clips and greens together? All together? Thanks. Go on to the last one. Y'all ready for the last one? Yes. Okay, you bring them back. Y'all on paper clip this way,
Oh yeah.
Y'all see what I'm doing that one? I actually think Okay, I'm gonna give you guys 10 more seconds. You should have everything for each all the way to the white cards. I don't believe Can you not? It's just a graph. Up for down. Some numbers. So right now. Alright. Few seconds. Paperclip any last ones so I can come by and pick them up later. Bring it back. 5, 4, 3, 2, and 1. Turn those seats around if you're talking to someone. Okay. We got 10 minutes left, and I want to use about 5 minutes for our exit ticket, which means we got about 5 minutes to wrap up what you guys noticed and put some definitions to these things, these transformations of waves. These parts of our graph actually have some special names with sinusoidal functions. So, A, super quick, someone cheer out. What did A do to our graph? One.
Like the higher and lower the numbers, it's like the maximum.
Max and min. So it was vertically stretching or compressing our graph like this. Cool. For B, B was doing what? Adrian?
Yeah, what's the horizontal stretch right?
Horizontally, and so that had to do with if it compresses it, there could be like lots of them, how often the wave repeated. And the last one, D, was just what, Leslie? Translating it, shifting it up or down. We did not do shifting left or right. That's the one we're missing today that we're going to talk about later. So these parts of the wave actually have some names. If you were in AQR or have seen this before, or even honestly some of this might seem familiar with physics with some of the stuff you've done with like frequency and stuff like that. These sinusoidal functions, our A, our B, and our D value impact parts of the graph that we call different things. So the vertical compression or expansion, which was our A value, is going to affect a change in the sinusoidal functions, what we call amplitude. The amplitude is the distance from like the middle of our wave to the minimum or to the maximum, like Juan said. That first value was like about the minimums and the maximums. So it's the distance from the middle to the minimum or the maximum. We call that the amplitude. So visually, we're talking, here's our wave. This distance right here is our amplitude. Okay? Right? Like if there was a 2 there, it went to 2 instead of just to 1. Okay, so for the normal sine function, our amplitude is 1. When we put a different number in front, it changes the amplitude. Okay? Next up, we define the sinusoidal functions, horizontal compression or expansion. That is going to change what we call the period of the function. These things repeat periodically, so it's like how often does it repeat? What is the length of one full rotation or one full cycle for our function?
This is the B one.
This is the, good, I forgot to write it. This is the B value affects how often it repeats. So if there is no B value, if it's our regular sine function, one full cycle had a length of, remember, 2 pi, and then it started repeating. So the period was 2 pi for our normal sine function. Alright, and last but not least, the function's vertical shift is a change in what we call the function's midline. That's going to affect the midline of the function, which midline sounds like middle. So it's like the middle of the wave, which in our normal graph is the x-axis. But if you shift it, now it's like a dotted line, an imaginary line in the middle of the wave. So it's like the new horizontal axis if you shift it, or the line about which this wave is like oscillating above and below. So tomorrow we're going to come in here and you're going to see something very similar to the problems on your problem set where I'm like, here's an equation, find the amplitude. Here's an equation, find the period. Here's an equation, find the midline. And so if we know where the graph has been shifted or stretched or compressed, then we should be able to identify those things and kind of come up with some rules for them. Okay? Once you have this stuff jotted down, you can go ahead and put your notes away and silently and independently. Like I said, we're going to start doing. I want you to grab one of these exit tickets from your table. Silently and independently, I want you to show me what you know in the last 7 minutes. Drawing sine and cosine. Talking about what type of transformation is happening at the bottom. And then if you have time, go on to the multiple choice problem on the back. Let's see if we can walk out of here making sure we know what sine and cosine look like and what type of transformation is happening. If you remember them, put them, because I want to see like as much as you know and could remember walking out of here without trying to look. Yeah. Sine and cosine. So you gotta remember which one's which.
I didn't see that. That's right.
Cool. Notice the multiple choice question on the back is worded a little different, but you're looking for the function that describes the y coordinate around the circle. So think about what that means and which graph matches a graph for the y coordinate as you go around. If you're done, just hold on to it because we're probably going to have maybe a minute to check at least part of it before we get out of here. But keep your voices off if you're done. Stay silent for people to finish around you. Alright y'all, we still got 4 minutes, so if you are done, you can switch over to a pen or we're gonna trade with the neighbor. So if you used a pen, just make sure it's not the same color as whatever they were working with. And we're gonna trade and grade in our last 4 minutes.
Like, it's really good to defend yourself.
You can like start to do this, but like we didn't specifically talk about that's right. Do you remember what we did in this came from? A. Right? So like we really do have enough information, but I didn't like practice one that looks like that.
It might hurt, but my hand's gonna break.
Right, because you saw on here that the ground was go up. But I'm gonna check this, but we'll see once we get started on it. Okay, eyes up here. I'm still going to grade it, and I'd love to get you out on time, so I'm gonna ask for voices off, pen in hand, someone else's paper in front of you. Thank you very much. Okay, for the first one, sine, correct? Our wave needs to start, make sure the person starts, Jason, where?
At 0.
At 0, and it should go up and should show this, and they might have shown more of the wave, which is fine. I'm fine if today they just sketched this part of it, but I do want, moving forward, we should also know this goes up to what?
1.
Down to what? And how much is one of these waves? What's the period of the function? 2 pi, it's a full circle, and then it repeats. So we're going to move forward, like on a quiz or test, you need to label the period, which means what one cycle is. Even if you kept going, I want to see what that length is to the first wave. Okay, for cosine, we're going to go starting at 1, like this. So check that their wave starts not at the origin, make sure it's not at the origin, starts up somewhere. If they didn't label it, just label it for them, and goes down and up. If they have more than 1 rotation, that's fine. I want to see at least 1. And we'll do one more. We'll do just the one at the bottom. Okay, we'll do both. It'll be really quick. The one at the bottom is just up 2. Okay. On the back. It says it's describing the y-coordinate, so which sinusoidal function is that? Sine or cosine? Sine, and the only graph of sine is A. The other one's either cosine or thing. Counterclockwise is what we did. Didn't we go counterclockwise? Yeah? Make a pile of these on your table, pack on up, stack your chairs, and you may get out of here.
I'll show you anything. I want to beg. I'll show you anything. I just want to beg. How do you guys? Okay, what are you doing? In the gym? Yeah, I know you want to. Where do you have to the college? He does not do 600. He does like, I would guess, too much. Yeah, so what is something max? Real chest. I can still have it. You can do 50 chest. I can 205. I'm carrying on my chest. Talk about real chest. Over 600, that's a line. That's way too much. That's not bodybuilding. That's over. That's bodybuilding stuff. That's over bodybuilding. Yeah.
We had water homework today.
That's like.
I finished one game for the water game. I still didn't finish up this class. This homework, the sister is like, don't pull it out, pack it up. I was doing his homework, so I still got like 2.
The world record is 7.
Yeah, what's up?